All right, gang, we're on the back of this worksheet where we're going to look a little bit at how to graph these. I know we've talked about this before, but just to keep some things in mind. So the first one is to graph 1/4 to the x power. And again, I think it's always best when you're first graphing something, maybe on the side of the paper on scrap paper, just give yourself a little cheat sheet, right? Plug in some simple numbers like 0, 1, and 2, just so you could see what's going on. Of course, anything to the 0 power is 1. So there we go. Almost all of these exponentials hit 0, 1, unless you do some kind of shift, either vertically or horizontally. And if you plug in 1, I get 1/4. If I square things, I get 1/16. And already you can see what's going to happen. Right, at 1, you get 1/4. That's about here. At 2, I get 1/16. And then you could already see there's the horizontal asymptote that I totally anticipate at y equals 0. I guess we'll throw that in there, 2, 1/16. That was good to label a couple of points. And then just take a peek on the other side. -1, of course, would flip 1/4 and get 4. And -2 would give 16, and already you're off to the races. Like -1 would give 4, and the next one is already up at 16, and there you go, right? And of course, my horizontal asymptote, just as a reminder, is at y equals 0. There it is. By the way, decreasing as you go left to right, and why? The base, which is equal to 1/4, is less than 1. If the base is less than 1, you're going downhill. Bigger than 1, you're going uphill. So all these are fairly simple graphs. There's 2 to the x. Like that was the first function we graphed. Again, it hit 0, 1, horizontal asymptote at 0, and I'm not going to put a lot of work into this one, right? 2 squared, that would give you 4, and I guess -2 to the -2 would give 1/4, right? So that one, and of course, the base here is 2. All I care is that it's bigger than 1, so this is why this is an increasing graph. All right. All right, here we go. 16 times 1/2 to the x. By the way, the base here is 1/2, so I know I'm a decreasing function. And again, just, give yourself just a couple of points, because once you have 2 or 3, it's almost like a line. Once you have 2 or 3, the pattern is so familiar that it's going to be hard to screw up. So here, if you plug in 0, you actually get 16. Now, of course, I always said 0, 1 is on all of these, but you're multiplying by 16 in the front. So it's like you have this vertical stretch by a factor of 16. So here's 0, 16, like this, right? Let's label that. And then, just pick a couple of points. If you put in 1, you're down at 8. 2, you're down at 4. So you can see you're already going downhill. Right? And if you keep dividing by 1/2, you'll be getting closer and closer to 0. So here's 2, 4. And then on the left side, you can anticipate it's going the other way, but let's just plug it in. So if you put in -1, that flips the 1/2 to give you 2, and 2 times 16 is 32. So it's doubling up on this side, right? It's going off to the races. So already at -1, you're already up here at 32. And I apologize, this is totally not the scale, but it gives you the idea, right? It's decreasing function because of the 1/2. Again, my horizontal asymptote at y equals 0. And it's similar to like all these functions, except the 16 just made the y value a lot bigger. It's the only difference. And then finally, I have 1/2 times 4 to the x. You can kind of finagle with, if you really want, you can get a common base of 2, but I don't even think it's necessary. Again, I would plug 0 into this. 0 would give 1/2. There's 0, 1/2. The base is 4. That's bigger than 1, so I'm going to have an increasing function. Let's plug 1 in. I'm not even going to make the chart. I think we could kind of do this mentally. If you plug in 1, I get 1/2 times 4 is 2. So at 1, I'm up at 2. And then if I plug in 2, I'll get 1/2 of 16, which is 8. So here's 2 comma 8. And we're kind of off to the races on this side. Big surprise. And then again, if you plug in -1, you'll get 4 to the -1. That's a quarter. And then 1/2 of that is 1/8. So at -1, you're at 1/8, and you can see what's happening. I keep decreasing ever so slightly down till I get that horizontal asymptote. So -1 again gave 1/8. What would -2 give? 1/32? Yeah, it just really gets small. So that's how to graph that. So exponential growth is, of course, when the base is above 1. Exponential decay, or a decreasing function, is when the base is less than 1. By the way, if the base is equal to 1, you don't even have an exponential function, because 1 to the x is just 1. You'd have a linear function or a constant function. And the horizontal asymptote, again, it's always at y = 0 unless you shift the graph up or down, which is obviously not what happened here. All right, guys, take care. I hope that helped.